My name is Joseph Odhiambo, Kamudanga Farm Manager. Kamudanga is a fish farm located in Machakos County at the foot of Moa Hills. Kamudanga Farm has adapted a technology in fish farming which is called recirculatory aquaculture system, in short RAS. A RAS technology, among other technologies in fish farming, we have several. We have pond farming, we have cages, we have raceways. But now with the limitation we are now getting in the current world of fresh water, we are now forced to adapt technology in production of fish, whereby we look at the water budget. And RAS has proven to be one of the best technology in utilizing little water. As you can see, the farm is located in Machakos, which is known to be a semi-arid area, some parts, but we still manage to do a lot of production within a very small space because we are economizing in the use of water. So we are economizing in a manner of the way we are using the technology. A recirculatory system is whereby water goes to the filter and come back to the fish. So we are not wasting that water. Mostly in fish farming, we normally have two challenges. The waste removal, we have two types of waste. We have the solid waste and we have the dissolved waste. So any farmer that is growing fish, main focus should be on waste management. So if you have the filter, you run water through the filter. Like now we have two types of the filtration, biofiltration and sedimentation or mechanical filtration. So as water is pumped from where the fish are into the mechanical filtration, the solid or the fecal waste settles there. And once the solid has been removed from the fish water, you can reuse that water again. That's why it's called a recirculatory aquaculture system. Another type of waste that bothers most of the fish farms is the nitrogenous waste. We call it ammonia, nitrate, nitrate, all that. So if you overlook such challenges, then the problem, you will encounter a lot of problem in fish farming. The dissolved waste, we manage it through the biofiltration system, or you can call it a fish biodigester, set right in the middle of the fish tank. The big tank with where we culture the bacteria. The bacteria now, they are naturally occurring bacteria. They just develop in the aquatic system. So once you run it for like 2 or 3 weeks, the bacteria develop naturally. They consume the fish waste, which is the nitrogenous waste. And then now the fish is in an environment where it is a waste-free environment. As long as the fish is kept comfortable, they're not struggling in their own waste, like the fecal waste and the dissolved waste, the fish will be very happy and they will grow to market in a very short period of time. The technology, as you can see the structure here, it takes different design depending on the location. Like here we are doing indoor fish farming. All the fish are done indoor so that we manage the temperature. Temperature has been the key factor in the production of fish. For example, if you grow the fish at a temperature of less than 20 degrees, it can even take 2 years before fish get to the market size. Fish farming is all about controlling the inputs, the factors, like now the waste, and now the temperature. And another most important thing is the oxygen. If you look at the system, the way we do aeration, we do a lot of fish per unit area. Traditionally, people are known to be doing 4 fish per square meter. Here we are doing over 135 fish per square meter. That is far beyond the natural carrying capacity of water. And that is only necessitated by the aeration and the bubbling you see in the tank. So if you see the aeration, that is now you are increasing the capacity, the holding capacity of units. The machines that we are using electricity to pump oxygen into the water, and now we are able to sustain a very big biomass per unit area. So with that, you find that you have utilized the smallest space possible and give the highest production ever at a very faster period of production and shortened production cycles. Intensification is the solution to food security. because we have a lot of mouths to feed and very little. We were importing fish and we can't do that anymore because we have to support our local industry. And by supporting local industry, investment is required. It's not coming up as a miracle. We need some, like this technology is we can say it needs quite an amount of capital investment. It comes at a cost. So the cost being the installation of this equipment, running cost of the electricity. As you can see, this system uses power. And for any farmer that would now aspire to do aquaculture using this technology in growing fish, you first do your self-audit. What resources do I have? Like now the water. Do you have the capacity to sustain the aeration, running those pumps? And the water, the best source of water should be borehole is the best source of water. The surface water, to some extent, can be also used, but now you need to access you do the test so that you make sure that you don't run into risk of introducing diseases into your farm. All farmers outside there, the future of fish farming is in RAS technology, because as a farmer you are able to manage all the inputs and variables that are in fish farming. Unlike the ponds, you leave it to the environment. You can't control temperature, you can't control waste, therefore you cannot control production. And then with that all information, it means that we are not certain of solving the food insecurity.